Hello everyone, welcome to this part of the lesson for today. Now today we're going to look at chapter 2 real numbers, part 3 rational numbers. Now here are the lesson objectives for today. So number 1, you are able to classify real numbers, rational numbers and integers that include some of the numbers such as fractions, decimals, okay, and looking at irrational numbers. Alright, so without further ado, let's begin. Identifying rational numbers. So what are rational numbers? One of the main characteristics of a rational numbers are that they are a number that can be expressed in the form a over b, where it is actually in a fraction form, and such that the numbers a and b are both integers. That means a whole number. And of course, the denominator, the b over here, cannot be equals to 0. So it's actually any fraction numbers are actually all rational numbers. Now, what are some of the ways to identify and recognize rational numbers? Okay, so one of the ways is to look at terminating numbers. Okay, what are some of the terminating numbers? So all terminating numbers are considered as rational numbers, which means terminating numbers are actually looking at integers, numbers that are whole number. Okay, and terminating numbers are also looking at numbers with a fraction. Okay, so in general, you already know that if as long as I have an integer, a whole number, and I have a fraction, it will definitely be a rational number. Okay, so then what else? What other type of ways to identify rational numbers? So what happens with a number that is actually a repeating decimal? So another type of irrational number that we have is numbers that are repeating. We've called it recurring decimals. Okay, recurring numbers. Recurring numbers may be in decimal forms, but these numbers do not end and they repeat with a certain particular pattern. Okay, so for example, if I have the number 0.345, 345, 345 dot dot dot, you notice that this number 345, this our number keeps on repeating itself. So actually this is a recurring number, can be written as the form 0.345, where the first dot is at 3, the number ends and stop repeating at the number 5. So from the start to the end, so it's just 0.345. Okay, so recurring numbers are actually rational numbers as well. Some of the fractions happens to be recurring numbers also. So for example, you have the number 1 over 9, which will give you 0.99999, and 9 is the only number that's recurring. So in this case, 0.9 can actually be written as a fraction. So a fraction is definitely a integer, a rational number. Okay, so in this case, we have these two types of numbers that are rational numbers. So vice versa, if I have others, okay, numbers in the others patterns, all these are called irrational number. Okay, so if it's not rational, it must be called irrational numbers. So what are irrational numbers? A few main types is irrational number is cannot be a fraction. Okay, so irrational number cannot be written as a fraction. Irrational number does not end, does not terminate, and irrational number does not have any repeating pattern. Okay, so some of the common irrational numbers that you can observe and see, some of them are number 1, pi. Okay, which is actually very common. The numbers do not repeat at all. The decimal does not end as well. And you can have another number, for example, square root or cube root, okay, of prime numbers. So for example, square root 5, this is a number that doesn't end, and it cannot be written as a fraction, and there's no repeating pattern on it as well. So these are just some of the examples of irrational numbers. Okay, so it's next up. So after we know what are rational and irrational number, the next thing that we are going to learn about is how do we arrange in order numbers in order. There are two types of orders that we're going to look at. One is the ascending order, the other one is the descending order. So for ascending order, ascend means you move from small to big. So for ascending is going upwards, right? You're climbing up. Okay, ascending, going up the stairs, so it's from small to big numbers. The other one will be descending numbers. So descending number going from top to down, so this will be from big to small. Okay, so the question over here says arrange all the numbers in ascending order, right? So we can use that. And the question says circle the rational numbers. So first let us circle all the rational numbers first. Rational numbers are numbers that can be written as an integer. So definitely this is an integer. Okay, numbers that are fractions. So this is already a fraction. Let's take a look at the number. This number, square root 1/4 is a little bit questionable because it involves a square root sign. So let's take a look at actually square root 1/4. If you key into a calculator, it can be simplified as 1/2. So it's actually technically written as a fraction. So if it can be written as a fraction, it must be a rational number. So in this case, 1/4 over square root 1/4 is a rational number. Next, rational numbers are numbers that are terminating, that stops. So in this case, 2.04 is a number that stops itself. So this is also a rational number. Next part. Now we're going to arrange this in descending or in ascending order. So having all the numbers in fractions and decimals makes it difficult for us to compare a little bit. So what we're going to do technically, we're going to change -5/4 into a decimal. Okay, and this is actually -1.25. So we're going to compare them in decimal format. Square root 2 is approximately 1.41421. 35, so on and so forth. So I'll just write a few more decimal numbers just in case. And square root 1/4 gives me the number 0.5. Okay, so we're going to arrange from small to big. The smallest number will always start with the negative number first that we have. So in this case, the negative number will be -1.25, but we write the original fraction, okay, given the number given in the question itself. So it's -5/4 first, followed by the next number, okay, more than a negative number. The next one is a 0, okay, which is not a positive number yet, it's just neutral. So moving on from 0, let's start. What is slightly more than 0? So the next slightly that's more than 0 will be the number 0.5, right? So but we do not write the number 0.5, write the original number. So square root of 1/4. So slightly more than 0.5, we are now left with the number square root 2 and 2.04. So square root 2 is actually 1.14. So the next answer will be the number square root 2. Then the largest number will be 2.04. Okay, have you gotten your answer? Let's move on to the next question. Okay, first part, let's circle our rational numbers. Now, the first number over here, this is a negative square root 4. What's the square root for? Using our calculator, negative is outside the square root sign. So negative square root 4 itself gives you the number -2. And I know pi is definitely an irrational number, but it's approximate by the number 3.14159, so on and so forth. Okay, decimal continues, right? 11/17. I'm going to change it to a decimal. So press the S to D button on your calculator to change it to decimal. So you get 0.64705 onwards. Okay, last but not least, negative cube root of -8. Negative cube root. Do you know how to press the cube root button? Press your shift Then look for the square root button, then you will have a cube root appearing. Okay, take note that this negative sign over here is outside the square root sign, and then we have one more negative sign inside the square root sign. Okay, and we get our answer over here. This can be simplified to the number 2, right? And we have the number 3.25. So now, okay, let's circle out all the rational numbers. Firstly, rational numbers are all the numbers that can be written as a fraction. So obviously I have 11/7. Okay, numbers that are integers. So, well, negative square root 4 is an integer. Negative cube root -8 is also an integer. Number that stops and terminates, so 3.25 is a number that stops and terminates. And obviously pi is going to be an irrational number, so we're not going to circle that number. Now let's arrange these numbers in ascending order, starting from the negative numbers first. The more negative the number, the smaller it is. So let's start with the smallest. Negative number in this case is the number -2. Alright, but we do not write the number -2. We use back its original number over here. So I'll put negative square root 4. Let me change my color. Okay, after my negative number, let's move on to the next one. 0, nearest to 0 will be the number 11/17. This is 0.64 something. So it will be 11/17. Followed by the next slightly larger number, that will give me the number 2, right? But I'm going to write my original negative cube root -8. Okay, so after 2, so now we are left with the next few numbers. We only have pi. Pi is the number 3.14159, and this is 3.25. So pi is actually smaller. So we have pi and followed by the number 3.25. Have you gotten the answer? Okay, so if you have gotten the main concept for handling this type of question, I'll leave you to practice the other remaining questions, C, D, E, and F. Right, and then we'll check the answers for C, D, E, F, G. There's still a G, is it? Okay, let me take a look at the next page. No, so we shall finish up this page over here until question F. Okay, now in the next part of the video for today's lesson, we are going to examine each of the following statements, okay, to see whether are the statements really true or false. So the first question is, an integer is a rational number. Oh well, that's definitely true because it's in our definition, right? A rational number can be written as a fraction, okay, and an integer is definitely a rational number. It can be written as any number over 1, so it is a rational number. Okay, a rational number is always an integer. What do you think? Is it always an integer? Oh well, a rational number can become an integer, but it's not necessarily always an integer. So this statement will be false. Okay, next one. A fraction is not a rational number. Oh, that's definitely not true, right? Because a rational number is a number that can be written as a fraction. So definitely this statement is false. Okay, a rational number can be written as a fraction. So definitely a fraction is a rational number, right? Next one. Every rational number is a real number, right? This statement is true. Every rational number has a value attached to it. So if you can find the actual value itself, then it must be a real number. Okay. Next part of the statement says a real number is always positive. What do you think? Oh well, we have negative numbers and they are numbers with a value. That is also considered a real number. So in this case, this statement is false, right? So a negative number is also a real number. And a real number need not always be positive. It can sometimes have negative value as well. Okay, next one. A whole number is always an integer. What do you think about this? Definitely it is true. Have you gotten the answer? Last but not least, last statement. Fractions and decimals made up a set of integers. in this case, can an integer have a decimal place? Alright, so in this case, this is actually false, except for the case you're telling me 2.0, right? If let's say you put a dot zero itself, then that's definitely a decimal, but it's actually a integer at the same time. But if you have numbers that look like 2.1 and so on and so forth, the other decimal place have other place values, then that's not going to be an integer. So have you gotten these answers? Now, next part of the lesson over here, part B, is to test your calculator skills. Okay, do practice calculating the answers. Okay, and if you would like to, you can actually scan the QR code over here to check the final answers for all this. So I'll leave you some time, okay, to try and practice your calculator skills, find the buttons, and finish up example 3 over here. So with that, I'll end off for this part of our video and give you time to do the work on the previous page and this current page. I'll see you for the next lesson. Bye bye.